For the math warm-up today, what I would like for you to do is number your paper or dry erase board from 1 to 4. And I would like you to rename each of these fractions or mixed numbers. So think about trading. What could I trade for what, and what would my answer be? Go ahead and pause your video and see if you can't go ahead and figure out these 4 problems. Okay, so let's see how we did here. So for 5/3, I traded 3/3 for 1 whole, which gives me 1 2/3. Did you do the same thing? All right, let's take a look at the second one. 1 4/5. I traded 1 whole for 5/5. And then, of course, you take that 5/5 and add it to the 4/5 that's already there, and you get 9/5. The third one, we have 21/5. Trade 20/5 for 4 wholes, and then we get a mixed number of 4 1/5. And for our last one, 4 1/8, I traded 4 wholes for 32/8, and then I add that 32/8 to the 1/8 that was already there, which gives us 33/8. Okay, so let's take a look at our math message today. A city zoo has an orangutan that is 50 inches tall, standing upright. Is the orangutan taller or shorter than a 4th or 5th grader? Be prepared to use your class height line plot to explain your answer from the previous lesson. Go ahead and pause your video and write your response. So some of you might find it difficult to answer this question because the orangutan may be taller than some of our 4th or 5th graders or shorter than others. So what do we do about that? That makes our comparison difficult. And the reason it's difficult is because we have so many data points. So what might be easier for us to do is figure out the typical 4th or 5th grader height and then even it out. So for example, if I have 5 cubes and I have a 3 cube stack, so I've got a 5 and a 3 cube stack there. What could we do to even out the heights of these towers? One thing that we could do is take 1 cube from the 5 cube tower and place it on the 3 cube. So if we cross that out and we're going to put it down here, now we would have the same amount on both sides. So we can think about evening out the height of the towers this way and combine the height of both towers. So we would have 5 plus 3 equals 8. And then we're going to take 8 and divide it by 2, which equals 4. So basically, we're finding the average or the typical height of these towers. So let's look at another example. So looking at this next example in my great artwork, we have a tower that has 4 cubes, we have a tower that has 8 cubes, and we have a tower that has 9 cubes. If we wanted to, quote, get the typical height of the tower or even out, what could we do? We could add these all together. So we could do 4 plus 8 plus 9, which equals 21. And then because there are 3 towers, we would take 21 divided by 3, which equals 7. And that would be our typical measurement for these towers. So basically we're taking those numbers, we're adding them together, and then we're dividing by the number of object or towers or whatever it is. So our lesson today is called Working with Data in Line Plots. The reason we are doing this lesson today is to be able to continue using line plots to organize measurement data to solve problems, and to realize that sometimes there are too many data points, so we need to even things out. So how we're going to go about that is learn how to even out data points, and we're going to learn how to calculate the typical of something. So some strategies and some things to think about as we go about this today. We want to ignore fractions and round to the nearest whole number. And this is going to be useful in some situations where you don't have to be as precise. And we're going to use a calculator and change fractions to decimals. So let's take a look at this line plot that I have placed here for you today. So you'll notice that my data points have fractions and mixed numbers here, and we were talking about strategies earlier and how sometimes we need to ignore the fractions and round to the nearest whole number. But in this instance, what do you think? Do you think that we need to ignore the fractions and round to the nearest whole number? Look at your data set here. Look at how many x's we have for each of these data points. There's quite a few. So for this particular one, I don't think we want to ignore the fractions. So how would we go about, quote, evening out or finding the typical readers, like how many hours that they spent reading? We would need to take these mixed numbers and turn them into decimals. And then we would add all of these together and divide by the number of x's that we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26 data points. So we are going to divide by 26. So I'm just going to write 26 up here because we know that's the total for the data points. So that's what we're going to divide by. And then we need to take each one of those mixed numbers and turn them into a decimal and add them together. Now you might want to get out your calculator to do this activity. But just so you know, 1 1/4 is going to be equal to 1 25/100. And of course, 1 1/2 is going to be equal to 1 50/100. And 1 3/4 is going to be equal to 1 75/100. And so again, when we use the 1/4 here, it'll be 2 25/100. That'll be 2 50/100. And this will be 2 75/100. So go ahead and pause your video and see if you can't go ahead and add those together in decimal form and see what answer you come up with. Okay, so I added all of those up and I got 55 25/100, and we're going to divide that by 26, which is going to give us 2 125,000 for our typical person hours of reading for this particular example. How did you do? Were you close to that? So let's take a look at another example and do a little bit more practice here. So now we have a line plot that's showing us number of candy bars, number of students that I'm assuming ate them or whatever they did with the candy bars. But we can see here that we don't have any fractions. They're all whole numbers. However, our data set is pretty spread out. So again, we need to find a typical or an even out kind of deal here to figure out how many students had an average number of candy bars. So with your calculator, you're going to add up, let's see, you'd add 1 plus 2 plus 3 plus 3 plus 3 plus 5 plus 5 plus 5 plus 5 plus 6 plus 6 plus 7 plus 8 plus 8. And we're going to divide that by the number of x's that we have. So go ahead and pause your video and see if you can't figure that out. Okay, so let's see how you did here. I got a total of 67. There were 15 total x's in the line plot, so I did 67 divided by 15, which gave me an answer of 4,666 ten-thousandths. Now, when we get a decimal, which when you do this on your calculator, it's going to repeat for several places and then you have a 7. The easiest thing to do in that situation is just round that to 4 47/100ths. So that's what we would do with that particular answer there. So as you can see, the average or the typical student had 4 47/100ths candy bars. So let's summarize what we've talked about today. We learned that we can even out or find the, quote, typical amount of data by adding all of the data amounts together and dividing by the number of data points for a particular measurement. Sometimes we need to round to the nearest whole number, and other times we can use a calculator to be more precise. So I think you guys will be awesome with this lesson, and we will practice in class. See you then.